Hello everyone and welcome back to another video. Now this video is the second part of the Linux Masterclass course. So in the first part we covered a lot of things. As you can see in front of my screen, I'm showing you the timestamps of the first video where you can see that we covered a lot of commands and a lot of history behind Linux and understood a lot of things on how they usually work in Linux. So if you haven't checked out that video, then do make sure to check that out. The link to the playlist for the Linux Masterclass would be in the description below. And this Linux Masterclass is also a part of the Web Development Bootcamp. So if you're interested in a Web Development Bootcamp, then also the link to that playlist would also be in the description below, so you can stay updated with these two playlists, because whatever videos I'm going to add that are going to be directly related to the Web Development Bootcamp or the Linux Masterclass, I'm going to keep adding those videos into these playlists. So you can stay updated with these playlists. The link to these playlists would be in the description below, and you can also find these playlists in my YouTube homepage. And as you can see, this is the Web Developments playlist, the bootcamp, and as it says, no degree required, so you don't need a degree to be a part of this bootcamp, and you can without being from an IT field or without having a degree, you can still aim to get a good job in computer science. So that I can guarantee if you you know st- do the hard work that it takes. And this is the playlist for the Linux Masterclass course, so you can stay updated. And now, without any further ado, let's get started. In the last video, we learned a lot of commands, right? We learned a lot of Linux commands and we executed a lot of Linux commands. But let's just try to understand, how Linux, what Linux actually does when we actually try to execute a command, right? So let's say I type a command ls, which is to list down all the directories that are there in my home directory, and by default Linux usually opens up the home directory for me, right? So when I press the ls command, I can see all the directories that are listed down in my home directory. And if let's say I mistype the command a little bit and instead of ls I typed lg, right, and I press enter here, this time it gives me an error, right? So in the first scenario, it took an input from me and then it gave me an output, like the output that it was supposed to give. And in the second part, it took a command from me. It tried to execute it, but it felt like it's not able to find this command anywhere in the system, and then it threw an error saying that the command was not found, right? So what is happening here, like behind the scenes, when we execute a command, what is happening, like what is actually happening? So Linux by default has three standard streams, right? There are three standard streams. One is the stdin, right, which is the standard input. The second one that is there is the stdout, right, which is the standard output. And the third one that is there is the stderr, right, which is the standard error, right? So these are the three standard streams that are there in Linux, and they only have one job. Their job is to transfer data. So streams in computing world, it generally means that it needs to transfer data, right? And the data in case of Linux is just simple text, right? So it's like it is taking an input, the stdin, and then it is giving me some output. Now this output could be the standard output or it could be the standard error, right? So it is taking some input and it is giving me some output, right? And these streams, they usually, whenever you execute any command in Linux, these are the streams that come into picture, right? So Now input can be taken in any form. I mean, you can add some input through a text file, you can add some input through your keyboard, whatever it is. And similarly, the output can be given in any form. It can be, whenever you execute a command, the output can be either in a terminal window. Right. The output could be in, let's say, some file. Right. Or the output could be given to a pipe, right, which redirects it, right, maybe to some other command. So that is generally what happens, and these are the mediums through which you can generally get an output whenever you execute any command. So, and this standard input that is there, it has a code of 0, the standard output has a code of 1, and the standard error has a code of 2. Right, these are just numbers, just remember them in Linux. Like, the standard input is 0, the standard output is 1, and the standard error is 2. Right, and as you can see in front of you, there's only one input stream out of the 3 standard streams that are there in Linux, and there are 2 output streams, right, the standard output and the standard error. Right, so this is how it usually works. And just to show you an example, uh, what I'll do is, um, so the standard output generally is given through a greater than symbol. Right, so if you want to, let's say, redirect your output to somewhere, the standard output, then you can simply add a greater than symbol. Right, so just to show you an example, let's say that we know the output of this ls command, right, but let's say that I want to have this ls command, and I want to save this output into a file known as output.txt. Right, so I don't want it to display the output in the terminal, but I want it to send the output in a file. I want to store this output in a file. Right, if I press enter to this, right, I can see that the output is no more visible to me. But if I again do an ls command, I will see that the output.txt is now added, like, into my home directory. It created a file for me with the name of output.txt, and if I, let's say, check the contents of that file through the cat command, I can see that it's now giving me all the directories that were supposed to be in this file along with the output.txt. Right, so that's how it usually works. Right, now let's say that I go to my downloads folder. Right, I go to my downloads folder, and again, let's say I want to give its output to the file that I earlier created, which was inside the home directory output.txt. Right, so this time if I press enter, what do you think? I mean, do you think that it would have retained all the contents of this previous output.txt and added more content to it, the contents of downloads, or would it have been replaced? So what would have happened? Let's just check it. Right, so I do a cd dot dot, and I dot dot is to go into the parent directory, and I again do a cat and then output.txt. I press enter, and I can see that this time I only see a few things, right, a few files that are there and some folders and things like that. So what if I want to append the data to some file? Maybe I'm getting some output, and my objective or my agenda is that whatever output I'm getting in the terminal, I should get in one file, right, and without losing the output of the previous commands. Right, so if that is my agenda, that what I can do is I can again do this ls, but instead of a single greater than bracket, I can add two greater than brackets. Right, so this time if I press enter and then I do that cat output.txt, I'll see that after the after what was added previously from the downloads folder, the contents of the downloads folder, it has now added the contents of the home folder, home directory. Right, so this is how the standard output works. Similarly, if I want to take some standard input from a file, then instead of using a greater than symbol, I can simply use a less than symbol, right? Now the standard input doesn't comes that much, into use. So I mean, I'm not going to show you an example of that, but let's just jump to a standard error, right? So again, let's say that I have this ls command and I give it this, greater than symbol, which is to, you know, redirect its standard output, and I want to give it to the output.txt file. I press enter. If I do a cat on output.txt, I can see that it now has contents of all the home directory that I have. But let's say that in this command, instead of ls, I did an lg, right? What do you think would happen in this case? We know that this is going to give me an error. This lg command is going to give me an error because that command does not exist, right? But is it going to save that error into the output txt or not? It's a simple question, just think about it. Let's check what happens, right? So if I press enter here, I can see this time that it is giving me the error on the console, on the terminal, right? And if I again do a cat and output.txt, press enter, I can see that my output.txt this time is empty. So why is it empty? It is empty because it didn't get an output. Now you will say that there is an output, right? This was an output command not found, but this was not an output. This was not a standard output. This was a standard error, right? So since it did not get a standard output, it made the file empty. This output.txt became empty just because it did not get a standard output, but instead it got a standard error. And for standard error, it cannot just add some standard error into some file with a simple greater than symbol, right? So to tackle that, what we can do is we can simply add a 2 before the greater than symbol, right? And can you tell me why 2 and why not some other number? Because I mentioned it here, standard error always is denoted by 2, right? So when I do 2 and the greater than symbol and output.txt, if I press enter this time, I can see that the error is not printed. And if I cat the output.txt this time, I can see that the contents of output.txt has changed to lg command not found, right? So this is the basic 3 standard streams that go whenever you execute any command. It is the standard input, the standard output, and the standard error. The input could be from a file, it could be from the keyboard, whatever you're typing, and the output again could be either in the console or in some file. And in the third point here, I mentioned that it could be in a pipe as well, like some pipe from where it is getting redirected, right? So what did I mean by this? What did I mean by this? Right. And like before we get into that, let me just tell you one more thing, that if let's say sometimes we feel that okay, we are going to get an error, but we don't actually want to populate our console with all the error messages, and we don't want to save it in some file as well. So in that case, what I can do is I can simply type lg, right? It is going to give me an error, definitely going to give me an error. And let's say I remove the output.txt file, right? I removed it, so I don't have an output.txt anymore. If I type the lg command, it is going to give me lg command not found, but I don't want to get this error, right? So I can simply do this, and then I can redirect it to /dev/null. This will nullify any error that is there. It will not display it to the console, right? If I press enter this time, I don't get an error. My error is not saved anywhere. It has just become null, right? It doesn't matter anymore, right? So this is also one thing that is there. And coming back to this, so what did I mean by pipes and redirects? So if let's say that I wanted to ls with a long list and showing me all the contents of the /etc file folder, right? And /etc is quite a big folder in any Linux system. If I try to press tab a couple of times, I can see that there are 231 possibilities just in this folder, right? So obviously this is going to be big. I press enter and I see that, there are, just so many things that are out there, and my terminal is all, messed up because of this, and I don't want to actually mess up my terminal, right? So what I can do is, there's a command known as less, right? And what this less command does is that it opens, this output of this in a separate, window, which you can close and get back to this without printing the, the output in this terminal or this window, right? So it is a very simple, straightforward, basic thing. And just to show you that command, there is a file known as, so I'll press less, and there's a file known as var, and then slash log, and then slash syslog, right? So there's a file known as this. We'll talk about this a bit later. If I press enter now, I can see that it has, a lot of, entries, a lot of entries, and so many entries that would have populated my terminal. But just because I, opened this file with less, right, I can simply press q, right, to quit that window, and I can see that I came back to my terminal, right, without, that output getting printed here. So less is a very, useful command sometimes when you want to view larger files and you don't want to populate your terminal by viewing them. Now let's say that, again coming back to the command that we executed earlier, the ls then hyphen la, which is for a long list of all the contents in the slash etc folder. As we know, it has 231 possibilities, right? And we don't want to, just open it like this. If I do it like this, less and then ls hyphen la and then slash etc, it is not going to give me any output, right? But what I want to do is, I want to, the output of this, since it is so big, I somehow want to open it with the less command. So how do I do that, right? So I can simply type a pipe, right, and I can press less here. If I press enter this time, I can see that in another video, in another window, I'm getting the output of the command that I entered before the pipe, right? Now let's try to understand this. Let's try to understand what actually happened here, right? So I did an ls, then I did a hyphen la, and then I did slash etc, right? After this I added a pipe, and then I added less, right? So this is a command, right? This is a standard input that I have, right? And what is it going to give me? It is going to give me a standard output, the usual stuff, right? Now this pipe is usually shift backslash, right? It is just below backspace. So if you press shift and then backslash, it is going to give you this pipe symbol, right? So what this pipe does is, it takes, it takes the output of one command. So it took this stdout, right? It took this standard output, which was the output of this command. It took the standard output and fed it to the less as a standard input, right? So this is what it simply does. It takes the standard output of one command and feeds it to another command as a standard input, right? So this is as simple as that. The only job of pipe, because many a times, as I just showed you, this one use case where I, wanted to, view this entire thing in a separate window, but if I'm doing less and then ls hyphen la and then slash etc, it was not giving me the output. It was simply giving me some, random error, right? And I actually didn't wanted to, populate my terminal, and I wanted to open this in a new window. So how would I do that, right? So that's where pipe comes into picture. So it allows you to take the standard output of one command and pass it as a standard input to another command, right? So now it must be making sense, why I, taught you about the standard input output and the standard error streams, right? So that's how it usually works. And this could have easily been an error as well, but there are very few use cases where the first command's error acts as a good input for the second command's, input, right? So this was one thing. And now moving forward, let's talk a little bit about the environment variables, right? So I'll show you something, right? So we learned about the echo command in the previous video, right? So after echo, if let's say I do a dollar and then I press home, right, all in caps, right, to make sure this is all in caps, right? So if I press, type the echo command and then a dollar home, I press enter, it tells me that, location of my home. It tells me that my home is at /home/Apoorv Goyal, right? So that is what it does. Now let's say I do another echo command and this time I do a dollar and then a user, right? I press enter. It tells me that my username currently is Apoorv Goyal, right? So what are these, like what are these dollar home and these dollar user? These are the environment variables, right? So these environment variables usually contain useful information that the shell and some other processes use, and we'll learn about what processes are later on in some other video. But for now, just know that processes are something that runs everything in your system, right? So these variables, these environment variables give useful information. They store and provide useful informations that the shell and these processes can use, right? And you can check out all the environment variables through a simple command env. If I press enter here, I can see that there are a lot of environment variables, a lots and lots of environment variables, right? Now I'll show you something, right? So all the environment variables that I have, there is an environment variable known as pwd, right? So if I do echo and then pwd, I press enter, it tells me that my present working directory currently is this /home/Apoorv Goyal, right? And if I, let's say, move to downloads, right, and I then do echo pwd, it is now going to tell me that my present working directory is /home/Apoorv Goyal/downloads, right? So in the last lecture, when I told you about the pwd command, you might be wondering that how does the terminal or the shell knows where you are in the system, right? It's simple. It just maintains an environment variable for that. So as soon as you enter the pwd command, if I enter the pwd command, it is going to simply echo the pwd environment variable that it would have been stored, right? So that's how terminal and the processes access these information through these environment variables. These environment variables, since they are variables, their values can change and their values keep changing over time, right, as you use the system and things like that. But these environment variables come in handy to this terminal and the processes that they're running, to some commands as well that you might try to execute, right? They come in handy there, and that's how they help, right? Now there is one very important environment variable, which is the path, right? Like this is one of the most environment variables. I'll just clear my screen and type it again so that it comes up in the top, right? So this path environment variable is the most important. Why? Because it contains all the paths that your system will search whenever you try to execute a command, and I'll show you one example. So you can see that here are a lot of paths mentioned. Here is the /user/local/sbin, right? This is one path. Then there is one path called, and these paths are separated by a colon, right? So then there's one path called /user/local/bin, right? Then there's one path called /user/sbin. Then there's one path called /user/bin, and so on and so forth. There are a lot of paths, right? But let's just ls, right, and ls into the user/bin, right? I want to ls into this, and let's just store its content into a file known as output.txt, right? Or very simple, let's just pass it into less, because we know it's going to be a lot of content, right? And we just learned about pipe, so why not use it? I press enter, and I can see that here it has given me a lot of things, right? And you will notice some of the things that are pretty handy. You must have used them. So there's one apt, right? We use it to install anything, right? Then moving forward, lower, there's one command known as bash itself, right? The bash is stored in one of the directories that were mentioned in the path. So whenever you try to access the bash command, it would be found from here, right? And all the commands that you usually execute, the cd command, right? The cat command for displaying anything, that is also there, right? And more commands that you're familiar with, the depackaging commands, all of them. The echo command is also here. So whenever you try to execute the echo command, just because it is there in one of the directories whose path is mentioned in the path environment variable, only because of that it is being able to get executed, right? It is getting executed. It has the env as well, right? It going forward, it will have the ls as well. Let me just quickly scroll down and show you. So here you'll see it has the ls command as well, and it has basically a lot of commands, right? So all the commands that your terminal can execute, they would be available somewhere in any of these paths that are mentioned here, and all these paths are separated simply by a colon, right? So whatever commands that your terminal or your shell can execute, they would be mentioned here. And just to like quickly check, I think there could be uh, some commands that we usually install, right? Like python 10. So whenever I try to run anything in python by using python 3 command, even python 3 is mentioned here, right? And if you are a node.js user or something, then just to show you, even the npm command is mentioned here, right? Even the node command, the node.js and the node is mentioned here, right? So if these commands are not mentioned here, then your system would say that command not found, right? So the command not found error comes when it is not able to locate these commands. And in the previous lecture, I mentioned that in linux everything is a file. So now it must be making sense, right? Everything is a file. Even the commands that you are running are simply a file, right? If it is not able to find that file, it is simply going to give you the error that command not found, right? So it goes as simple as that. Now with all that being said, let's quickly take a look at some of the basic commands as well. So there's a command known as head, which just simply prints the first 10 lines of any file, right? So again, the file that I showed you previously, the big file, right? The var and then log and then syslog, right? If I do this, it's simply just going to show me the top 10, the first 10 lines of that file, right? And what I can do is I can simply add a hyphen n and then 15, right? And this time it is going to show me the first 15 lines of that file, right? So head is a pretty simple command. If you have, let's say, a very big file and you want to quickly check the first few lines of that file, usually if you're into data science, if you're doing something into data science, then you usually just want to check the number of columns that are there, and what type of data does that column contains. If it contains a boolean, if it contains some number 0 1, if it contains some strings or some lists or dictionaries, objects, things like that, you quickly just want to check it out, right? Like what kind of columns are there and what kinds of content does those columns contain. So there the head commands come in pretty handy. And if you're wondering about this file, the /var/log/syslog, then this file generally shows the general messages and information regarding the system, right? So whatever is going on in your system, the general things, it is going to keep maintain a log into this file. And similarly, similar to the the head file, there is a command known as tail file. As the name suggests, it will give you what the last 10 lines of any file, right? If I press enter, it is going to give me the last 10 lines of any file that is out there, right? And again, I can add a hyphen n flag, which stands for the number of lines. I can do 15 and it will give me the last 15 lines. And one more cool thing that I can do with this is that I can press a hyphen f and I press enter, then it is going to update on the go, right? So it, let's say it printed the first 10 lines, as of now. And if let's say I do some activity in my system, and I come back here, let's say I open another terminal or something and I close it, then you can see that it added some things, some logs related to what happened with my system, just some general information. It is not readable as such, so don't worry about it. It doesn't, usually uh, its use case is pretty less, so don't worry about it. Again, I press Ctrl C, got out of it, right? So that was it for the head and the tail command. Now let's say I go back to the home directory and I don't have a file here. So let's say I create a file known as testing.txt, right? And let's open this file, and let's say that I have some things in this file. Let's say I add some name of some animals: dog, cat, pig, lion, tiger, and bear, and sheep. And let's say that I have all these things, that I have a fish and all those stuff. So I have these things. Now let's say that I have this file, and what I want is I can simply cat this file and see what all I have. So I can see that these are the contents of my file. Now I want it to be sorted for me, so I can simply do sort testing.txt. I press enter and it gives me a sorted version of that file. If I, let's say, add a flag called -r, it is going to reverse sort it for me, so in the descending order, right? So this was all about the sort command, pretty straightforward stuff. Then there is a command known as translate. It goes by tr, and if let's say that all the files that all the names that I mentioned, I want to convert it from lowercase to uppercase, right? So I'm simply going to do tr and then give give it a range from lower a to lower z, and then upper a to upper z, and then the name of the file. I press enter, and it doesn't takes an argument. So again, I mean to give it here, or let's just see how this is going to work. Okay, it's not a command. Wait. So this is it. I think what I need to do is I need to do a cat testing.txt and then give it to the tr, and then a to z, a to z. I press enter and I can see that this time it has uh, taken the output of the cat testing.txt, entered it into as an input to the tra-z lowercase and then a-z uppercase, and it has given me the output. So it converted all the lowercase into uppercase, right? So again, if let's say I had this file and I, let's say, created some duplicate. So I, let's say, had tiger 2 times, tiger, and then lion. I, let's say, had these 2 duplicates. I press across and then I do a unique and then testing.txt, then it is going to give me all the unique values out of it, right? I can simply do a -c here, and it gives me the number of occurrences each and every word has. So it says tiger has 2 occurrences, lion has 2 occurrences, all of them, the others have just one, right? And if I, instead of -c, I do a -u, it is going to give me all the unique values only. So it detected that tiger is not unique and lion is not unique. There are multiple values that exist for them. So excluding it, it gave me all the other values, right? And I could have simply done a -d, which is going to give me only the ones that are duplicated. So it is now telling me that tiger was 2 times like duplicated and lion was duplicated, right? But there's one problem, right? So let's say that I have this one file, and I remove the tiger from here, I remove the lion from here. Don't know why it went full screen. Okay, never mind. So I, let's say, removed the tiger from here, and I removed the lion from here, right? And I add it again, lower down the line. I add a tiger and a lion, right? I press and like I save it, and now if let's say I go with the unique testing, it is going to, this time it is not detecting it. Like tiger is here, but tiger is here also, right? But earlier it was, it was able to detect those duplicates. So the reason behind this is that this unique command that is there, it only works, when you when the duplicates are actually adjacent to each other. So if they are next to each other, only then it is going to work, right? And only because of that it was not able to work in this case. So according to you, how should we solve this? Like if let's say I want to solve this problem, how would I solve this problem? Or maybe you can, just pause this video and try to figure out a solution based on whatever we have learned so far. How will we be able to solve this? It's a pretty simple problem. Okay, so one solution to this is that I can simply sort the file testing.sort testing.txt, and this is an input. It is going to give me an output of the sorted, things, where I can see that the lion are adjacent and the tigers are adjacent, right? I can, add this output as an input to another command, which would be unique testing.txt. This time I can see that sorry, so I shouldn't have passed testing.txt this time, because testing.txt again has the same values. Now, so what I want to do is I want to take the the standard output of this, and that I want to pass just to the unique command, right? So if I do this time I will see that the lion and tiger are not getting repeated, right? Because this time what it is doing is it is taking the standard output of this standard input. This is a standard input, it is giving a standard output. It is taking that standard output and passing that as a standard input to this command, right? As simple as that. And that's why, I mean, when I did this, it was taking an input from this file, so it was just like executing two commands simultaneously without, having an effect of the output of this, because its input was coming from this testing.txt instead of the output of this. But this time its input was coming from the output of this, right? So it gave me the sorted version of it, right? So pretty simple problem with a simple solution. And there's one more, command known as wc, which stands for word count, right? So wc, usually if I do wc and then testing.txt, I press enter, it is going to give me a 10, 10 and 50, right? Now what this actually means is that if I, let's say, do wc and then I do a -l and I press enter, then this gives me the number of lines that are there. And if I cat testing.txt right now, I can see that there are roughly about 10 lines, right? So again, I mean, the first number that is there denotes the number of lines that are there. The second thing that it is going to denote me is the number of words that are there. And the third thing it is going to denote with -w, it denotes the number of words, and with -c, it denotes the size of the file in terms of bytes, right? So it says that it's roughly about 50 bytes, right? So now let's say I had this file gedit testing.txt, and I added one more here, which was um, monkey, right? It was a monkey, right? So this time if I again do that wc testing.txt, I can see that this time it's saying that there are 10 lines but 11 words and 57 bytes of size, right? So again, simple stuff. And why 57? Because I added a space and then a monkey, right? So that space is taking 1 byte of storage, and then that monkey is 6 characters which are like 1 byte each, right? So 7 bytes extra than the previous one. Simple stuff, right? So that's again a simple command, very simple command. And there's one more command which is known as grep, right? So grep is a pretty important command, and it is like one of the most common, text processing commands that the developers use. And it allows you to search files for characters, right? So to show you an example, let's say that I do a grep, and then in grep what I pass is pwd, right? And I do this from the env command. So I'm saying that take the env command, right? Whatever output it gives, pass it as an input to the grep command, and I want to grab the pwd out of it. I press enter. I see that it gave me two results, right? The first result is the pwd, which is the present working directory, which is my home directory right now, and it says that the old pwd, or the you know previous directory that was there, not the parent directory, the previous directory. The previous directory, also it is telling me that it is the downloads folder. So again, if I do cd and then hyphen, which directory would I go to? I would go to the downloads directory, right? And if I again do cd hyphen, I will go to the home directory, right? And if I, let's say, do cd dot dot, I'm going to go to the home directory, which is like literally the home directory, right? And if I do a grep pwd here, I can see that my present working directory is the home directory, and the old present working directory was my, like, the user directory, Apoorv Goyal, right? So grep is a commonly used command to find different things. And grep usually is, like, grep usually works with regular expressions. Like, regular expressions are heavily used with grep, so I'm not going to include regular expressions or grep in, like, grep and regular expressions has a lot more detail, and they, like, honestly would call for a separate video. So I'm going to do a separate video later on in this course, like, dedicated to the regular expressions, and we are going to explore, more of grep in those videos. But currently, just know that grep is, usually used to search some text in some file, right? And something like that, right? So yeah guys, that was pretty much it for this video. Now some of the more important topics are still left, and by that I mean that I still haven't covered the users and the groups, and I still haven't covered the permissions and processes and packages, and we also want to talk a little bit about the Linux internals. So the next few videos are going to be a little bit on the heavier side, about, you can expect about 1.5 to 2 hours of videos. So be prepared for that, because I mean there's going to be a lot of content to cover, right? And we are going to go in a lot more detail with all those things. And I hope you got to learn something in this video, even if you have some sort of experience with Linux. I hope that I explained things well enough, and took you into the details of stuff that we usually ignore, right? So whatever you learned in this video, do make sure to use the hashtag LearningWithApoorv, and do make sure to write some Twitter threads or some blogs and tag me in them, right? Share them with me and share them with the people. Learn in Public initiative, right? Do make sure to keep that alive, right? Because in the longer run it is going to help you, as I mentioned in my previous video as well. So Learning with Apoorv, use that hashtag, write some Twitter threads, write some blogs, right? Share it with the community, and I'll see you in the next one. Till then, bye.